We are going to look at multiplying polynomials, and the first thing that we're going to start with is multiplying two binomials, which you may also know as something you can use the FOIL method on, but I don't want to talk about the FOIL method. I want to talk about a method that's going to work with all multiplying of polynomials and not just a binomial times a binomial. What we want to look at is applying the distributive property multiple times to make this work. And the first thing that I want to do is I want to do an estimate of how many terms that I should get when I multiply a binomial times a binomial. So I'm going to count the number of monomials in each set of parentheses. In the first set I have 1, 2. In the second set I have 1, 2. And if I multiply those two numbers together, I get 4. So when I multiply a binomial times a binomial, I should get 4 monomials before I bring together like terms. So this little indicator helps me realize if I've forgotten a term. So the first thing that I want to do is I want to look at this very first term and just do distributive property of 2 over this set of parentheses. So I'm just taking my finger and I'm covering up one term and ignoring it. And then I'm going to look at multiplying 2 times this and then 2 times this. So 2 times x is 2x. 2 times -1 is -2. So these are my first two terms. Now I'm going to look at ignoring this first 2, and I'm going to come in here and look at distributing this term over these. So I'm multiplying 3x times the x and 3x times the -1. So 3x times x is going to be 3x squared, and I'm just adding that on to what I already have. And 3x times -1 is going to be -3x. So now that I've multiplied, I have 1, 2, 3, 4 monomials. That was my estimate, so I haven't missed anything. So at this point, I can bring like terms together and put this in standard form. So as I look through here, I'm looking for the biggest exponent, which is right here. So 3x squared is a part of the answer. Then I want x. Well, I have an x term here and an x term here, so I want to bring those together because they're like terms. 2x minus 3x is going to be -x. I don't have to put the 1 there. And now my constant. I have -2, bring this negative with it. So this is my final answer. This is in standard form for polynomials, and all the like terms have been simplified. So let's step this up a notch, and this is why we don't want to talk about FOIL here, because FOIL fails here. There's no singular first, outer, inner, and last terms that we can talk about here, because I have a binomial and a trinomial. The method that I just talked about using distributive properties still works here. I can ignore this first term and multiply this by each of the terms in here, and then go back through and ignore the second term and multiply this term by each of the terms here. So let's take a look at my estimate first. I have 2 monomials in here and 3 monomials in here. When I multiply those together, I get 6. So when I go through the multiplication here, I should have 6 monomials before I bring together like terms. So let's look at this. -5 times 3a is going to be -15a. -5 times 4a squared is going to be -20a squared. And -5 times 10 is going to be -50. Now I'm ignoring the -5 and looking at the 2a. 2a times 3a is positive 6a squared. 2a times 4a squared is going to be positive 8a cubed. And 2a times 10 is going to be positive 20a. So I have 1, 2, 3, 4, 5, 6 monomials. That matches my estimate. So I have all the terms that I'm supposed to have. So now I want to put in standard form and gather like terms together. Biggest exponent is 8a cubed, so that's coming out here first. Next I want squares. I have negative 20a squared and 6a squared. I want to add those together. Negative 20 plus 6 is going to be negative 14a squared. Then I want a terms. Negative 15a, positive 20a. I'm going to have 5a when I add those together, and then my constant, negative 50. So this is my final answer. So I multiply two polynomials, I get a polynomial back. That means I have closure. And then one last problem. I have a trinomial and a trinomial. Let's look at my estimate. 3 times 3. I'm going to have 9 monomials when I multiply this one. And we are continuing this distributive property. This time I'm ignoring the first two, multiplying this number by these. Then I'm going to ignore the outer two, multiply that by these 3, and then ignore the last 2 and multiply this by these. So ignoring the first 2, 1 times each of these is going to give me these things back. That's the great thing about 1, makes things go really quickly. Now ignoring the 1 and this first term, I have negative m times all of these. Negative times a negative is a positive. Watch for these sign changes to start happening. And then ignoring the first 2, I have 2m squared p squared. Then I have negative 4mp. And then I have negative 6m squared. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That matches my estimate. I haven't missed anything. So now I had independent variables of p here, independent variables of m here, and so what do I do about standard form? I would gather the thing with the most exponents with the biggest exponents to the left and then count down as you move to the right. So that is going to be this term here. Both of the variables have square terms. So we're going to use that one first. Then let's go with, we have a p squared, an m and a p, and an m squared. So let's use this term first. Any other mps with a p squared? I don't think so. So we'll put that one next. If we miss one and need to go back, we can continue to simplify. All right, so now let's do this p squared here, and this m squared, and there's an m and a p here, m and a p here, so I'll take the 2 minus 4 is negative 2mp, and we can go back in here and mark these off as we go too to help us keep track of which ones that we've gotten. That's probably good bookkeeping. P and then M here, so I'll use that same order. I'll bring the negative 2P down here, then the 3M, and then any more constants, we have just the negative 3. So I got that one, and that one. All right, so this looks like our final answer. This one was a big one. And so that's going to be our final answer. Shouldn't have anything else. You can double check again, see if anything can be brought together. This is about as simple as it gets. So that's going to be our final answer.